Hello guys, so today in this video we will solve the GATE 2021 questions of fluid flow and mechanical operations. So but before we go in details of the questions, okay, we will see like what was the marks distribution, how was GATE 2021 paper. Just a quick survey, okay. So let's come back to screen. So today, so as we can see it here, so we have like 12 subjects, okay. So out of which many of them are okay. Aptitude was 15, maths was 13, mass transfer was 11, heat is okay, fluid flow plus mechanical operation was also okay. But CRE, the marks got degraded. Like if you will check to till 2020, you will see the marks contribution from CRE was always more than 10. I will show you also. Okay, and PDC it increased and reached to more than like 10 marks. It's 11. It's much more. Okay, economics really unexpected. Okay, they contributed up approximately 9 marks, which was not expected. Now talking about CT, it was not expected. 3 marks was very less. Mechanical operation was okay. CPC was also okay. But there was one interesting thing in this paper, and which is the contribution of numerical type questions. It was more than 50%. Okay, 51 marks were contributed only from the numerical type questions. So now I think you should have to get serious with the GATE paper. Now it's not objective, just go with Akkad, Bakkad, Bombay Bo, 1, 2, 3, 4, Jai Mata Di. It can't be possible now. So they are slowly converting the whole paper to subjective. Now let's compare it to the last 11 years. So you will see, if you will compare it, so maths was okay. So maths was still 12 to 13 marks. Aptitude was 15 marks. It's okay. Fluid plus it was more than 10, and even in this case also mechanical operation plus fluid flow, if you will combine them, 8 plus 3, it was 11 marks. So it's okay. Okay, heat transfer generally comes around 6 to 8 marks. This time it reached to 9, but that's okay because half of the time it was more than 10 also. CRE always more than 10 marks, but this time CRE was only of 7 marks, so which was not expected. Okay, it was little off track thing, but that's okay, things change. Okay, so thermodynamics, it was generally 6 to 8 marks. This time also it was 8 marks, so it's okay. PDC 10 marks, only two times they cross more than 10. So this time again it's more than 10 marks, that is 11 marks were contributed from process dynamics and control. So that one was not expected. CT 5 to 7, generally 5 to 7 marks. Okay, we prepare a lot, we remember a lot from CT, but still this time only 3 marks. Okay, and finally economics 4 to 6, that's the maximum. Okay, but in this case 9 marks. Okay, that was not expected. It's very close to heat transfer, so economics got the equal importance to heat transfer of fluid flow. Okay, so that was not up to the mark, but IIT Bombay has made this paper, so maybe they have something in their vision to have this kind of paper. So overall I will say the numerical type questions, they got a very high importance, that is 51 marks. Okay, that's really, it was not expected. So slowly they are moving, completely converting that paper into numerical type paper. So you have to be little bit serious now. Okay, so that was the conclusion. So I will say some of the subjects, like I said, some of the subjects were contributed more marks, some of the subjects contributed less marks than expectations. Okay, but that's okay. But because like if you will compare mass transfer, heat transfer, fluid flow, thermodynamics, CRE, they are okay, except CRE everything is almost okay. So major subjects contributed in a good amount. Okay, now let's come back to the video. So in this video we will solve, like I said in the starting of the video, we will solve the fluid flow and the mechanical operation questions. So there was 7 questions. Okay, 5 from the fluid flow and 2 from the mechanical operation. So everything is concluded here, and first we will solve 1 mark questions, then we will solve 2 mark questions. Okay, so now moving forward with the first question. So the first question was from the fluid flow, where they have mentioned that there is a 3-dimensional velocity gradient, velocity field is provided to you, which is 5x square and cy and minus 10xyz in the z direction. Okay, so they are provided in the Cartesian coordinate system. Now they have asked like c is the constant, and they have asked what is the value of c if the fluid is incompressible. Okay, this word is very important here in this question. If you will understand incompressible, then it's like nothing. It's a 1 mark question, but you have to understand what is the meaning of incompressible fluid. So if I will go further, so incompressible fluid means density will not change either with the coordinate system. You either means you are going to x direction, y direction, or z direction. Wherever you will go, the density will not change. Even it will also not change with time. D rho by partial derivation of density with time will also be equal to 0. Okay, so it means we can apply continuity equation here. According to continuity equation, which is dependent on, or whose principle is the conservation of mass, says that if we will do the partial derivation of density into u plus partial derivation of density into v, partial derivation in density into velocity in the z direction, plus d rho by dt is always equal to 0. So the mass will be conserved. Whatever is entering into the pipe will exit in the same quantity at the other side of the pipe. Okay, that's the principle, that's the main motive of the continuity equation. So according to this formula, we can say that so in this formula, if we will say the density is constant, they mentioned it's incompressible fluid, which means density will not change, right? So it means the density here and density here will be taken out because it's not changing, and this will automatically will be equal to 0. It's incompressible fluid. Okay, so this will be 0. So we are left out with only d rho by dx and dv by dy and dw by dz. So velocity in the x, y and z directions, and which the summation of them will be equal to 0. So now the question is solved. We have the equation. They ask what is the value of c. We know the equation where we have to put everything. So you will take this 5x square y as u, cy as v, and minus 10xyz as w. So if you will put everything in the continuity equation and you will differentiate it, partially differentiate it. So if you will solve this equation, you will end up with 10xy plus c minus 10xy is equal to 0, and they will cancel out each other, which means you are left with c is equal to 0. So this was the question. You just have to understand what is the meaning of incompressible fluid. See, generally whenever the question comes, so people always thinks it's the continuity equation, you d rho by dx plus d rho by dy plus dw by dz is equal to 0, and we're good to go. Sometimes they may change the question also, so you have to understand all the perspective. Okay, so you have to understand what is the meaning of compressible and incompressible. They may give you the value, the density is changing with time, so you should know which equation you have to use to solve that specific question. Okay, so this question was only a 1 mark question. Just you have to, if it strike, it's good to go. Okay, now moving forward, so this is the official answer. So like I have included all the official answers which was provided by the IIT Bombay. Okay, so the official answer was 0. The option is B. Okay, now moving forward to the second question, it's a little bit interesting. Okay, you just it's about you should have a visualization, little bit visualization you need. Although mechanical operation is completely dependent on formula, you don't even have to understand a lot of concepts also in mechanical operations, but still this question was a little bit interesting. So what they mentioned is that you have a bowl, or you can say a big bowl, I mean a lengthy bowl. Okay, and you have two types of particles in your so you have everything with you. So you have two types of particles, A plus B, okay, mixed up. Now you are going to drop it. Okay, both of them try to settle down, they will try to settle down throughout the whole beaker or whatever the bowl you have, but the bowl should be long lengthy. It should be of a sufficient height, like they have mentioned here also. So the column is long column. Okay, so long column means it will reach the terminal velocity also. You just have to understand these things. It's not about like everyone will tell you every time that this is what is the meaning of long column and all those things. You have to Click something in your mind, like long column means they are trying to say that the particle will have sufficient time to reach the terminal velocity also, and that terminal velocity will help you to solve this question. Okay, that's the interesting part here. So they have mentioned that the particles are spherical particles, and A particles are of 30 micrometer size with the density of 1100 kg per meter cube. Similarly, B type of particle have 10 micrometer with 1900 kg per meter cube of density, and they follow the Stokes law. Okay, so now you have to understand what is the meaning of Stokes law. On that basis you will use a one specific formula, and then you are good to go. You just have to figure out, like, when you will leave the particles, both type of particles, so both are with you in one single hand, and you are just letting them to settle down in the bowl which is filled with the liquid, that is water, and it is moving all the way down. So they ask, like, when the particles will reach the bottom of that bowl or any column, so who will settle where? Either both will settle homogeneously, or A will settle first, then B will settle on the top, or it will happen the vice versa. And that's what they're trying to ask. Or only B will settle and A will never settle. That's what they are also asking here. Okay, so now let's try to understand this thing. But before we go with some basic definitions, so what is the meaning of Stokes law here? Like I said, the column is lengthy. Okay, so it means it will reach a terminal velocity. Stokes law says that it is applicable only when the flow is laminar flow, and second is the spherical particles. The particles should be spherical particles, only then we can apply the Stokes law. And they have mentioned its Stokes law is applicable, which means we know Reynolds number should be less than 0.2. Okay, Stokes law is applicable only when it's less than 0.2. That's what we have to do, right? So they mentioned that drag force will be applicable at that time will be 3 pi mu du, and drag coefficient will be 24 upon nre. So that's the formula that we use in the Stokes situation. But now in this question, when we solve these equations and we finally end up with this one, how do we end up with this one? Because in the Stokes law, there is the laminar flow, there is the particles are spherical, we already know it. They will settle down, okay, and finally they will reach the terminal velocity. So as the particle enter the fluid, the velocity will keep increasing because of gravitational force. But as the gravitational force will increase, the drag force that you see it here, this drag force, because in the Stokes law this drag force will also increase, because the velocity increases because of gravitational force, but this force is also dependent on velocity, so drag force will also increase with velocity. So there is a time when it will come, like the force that is going down, and there were two forces acting upward. One is the drag force, another one is the buoyancy force. There is a situation will arise when the downward force will be equal to the upward force. At that time, when they will be equal to zero, the summation, when they will be exactly the same amount will be, like one is in the y direction, one is in the minus y direction. If the amount of force will be equal, at that time you will reach the terminal velocity, and that velocity is the maximum velocity of the particle in the fluid. Okay, at that time when you will balance it, so you will reach the terminal velocity will be equal to d square by 18 mu density of particles minus density of water or any type of fluid where you are dealing with your particles into gravitational force into the g 9.8 meter per second square. Now we will put all the values in this question. So this question is repeated again. Okay, so now I am using that Stokes law regime, according to which dp square rho p minus rho g upon 18 mu, that's what we have figured it out now. So we will put all the values in this case. We know the diameter of the particle, we know the density of particles, density of fluid z, 18 mu is same because mu is the velocity of the fluid, and which is same, it's water in both the cases, right? So we will take terminal velocity of A and terminal velocity of B and we will divide them. Okay, so as soon as we will divide them, we will find, like, they will be left out only with the diameter and the density. Simple. So you will put all the values here, that is, and the densities were given, the diameter were given, so you will put them and it will be equal to VTA by VTB, that is the terminal velocity of A and B is equal to means 1, which means both particle will reach the same velocity, so both will reach at the same time at the bottom of the column also. Both have same terminal velocity, right? So it means both will settle down with the same speed. It means if you have everything at one place, as soon as you will lose it, so everything will settle down at the same time in the same manner. So which means consist of the system, the settled particles will be a homogeneous mixture of A and B. That's what happens when you will leave these two type of particles in the water where the column is long, which means the particle will have sufficient time to reach the terminal velocity, right? So that's how we solve the question. So you just have to, this thing you have, just like you have to click this thing, okay, and then the question is like nothing for you, just you know the formulas, like terminal velocity, you know, Stokes law, you know, it's just about the concept. It's just about some specific words in the questions that are sufficient to solve your question. Okay, now moving forward to the third question. This question is, I found it not too much interesting, just about you should remember few things and you have to put the values here and there and you are good to go. Like in this case, they have asked like alpha in the turbulent case is given to us, and on that basis this V naught by average velocity is given to us here, and this one we can calculate it from n is equal to 7. So we don't have to do anything. Put the value of n here, put this value here, and you will get the alpha value. But finally they ask what is the ratio of the alpha turbulent by alpha laminar. Now in this case they have not mentioned the value of alpha laminar, and that's what you should know. So in the case of alpha, in the case of laminar flow, the alpha value is equal to 2. Okay, and here we have to figure out what is the alpha value in the turbulent cases. So let's go further. So you know the first equation is already provided to us, which is V naught by average velocity by terminal average velocity, and this V naught is the center line velocity. Okay, and we have to put the value of n. So as soon as you put the value of n in this equation, you will be end up with this case. Now you will put it in the first equation which was given in the question, and you will have alpha turbulent as this will go here, and you will again put the value of n in these cases, and finally you will end up with 1.067. that's the value for the alpha turbulent. Okay, so now you just have to remember the alpha laminar is 2, so just have to put it in the formula alpha turbulent by alpha laminar, and the answer will be 0.53. That's the answer that you have to figure it out in this whole question. The question was nothing, you just have to remember the alpha laminar and it's like nothing. Okay, so before I go further with some new questions, I would like to share something. We have already uploaded 3 videos related to handwritten notes and related to books, what type of books you should recommend yourself, subject wise books, and third one is what are the best books for GATE chemical engineering. I mean, what I recommend you guys from which you should prepare yourself for the upcoming GATE 2022 or 2023. Okay, so these are the 3 books and 3 link that you will find it in the description box, and they will also pop up on the right top corner, so you can directly visit these videos and check it out if you will find it worth it. Maybe they will, hope so, they will definitely benefit you at some point. Okay, so now moving forward, so like this so we just solved the question, right? So the answer was 0.53, the official answer is 0.52 to 0.54. So our answer was 0.53 and it's coming in the range. So now we are good to go. Okay, so now moving forward to the next question. So this is our question number 4. So in the question 4 they mentioned that we have 2 horizontal plates which are at some distance from each other, and they mentioned that in the first experiment, because the distance is 1 mm, and they are observing a stress of 2 nanometer per meter square, wherever in the second where the top plate is moving at a velocity of 2 meter per second. So out of two plates, one will be stationary and another one is moving at 2 meter per second, and there is a stress between them which is 2 Newton per meter square. Similarly, in the second case, this distance has been reduced and the velocity has been changed. Okay, velocity changed, distance changed, and third one is stress, shear stress is also get changed. So now they are asking, like, if we have that type of fluid between the two plates, so which is that fluid? Like, is it Newtonian or non-Newtonian? In non-Newtonian, is it pseudoplastic, dilatant, or so they have asked pseudoplastic, dilatant, or ideal. Ideal means, well, viscosity is equal to 0. Okay, so another case is the Newtonian fluid. So they have asked like ideal, non-ideal. In non-ideal, Newtonian or non-Newtonian. In non-Newtonian, is it pseudoplastic or dilatant? So it will cover the whole concept about the type of fluid that we are dealing with. Let's understand this question. So in this question, generally there are two types of fluid behavior, actually three. One is the ideal and non-ideal also. Ideal means viscosity is equal to 0. But in the case of fluid behavior, we see there are two types of fluid, Newtonian and a non-Newtonian. What is the difference between them? That when you will draw a graph between tau and du by dy, so the line will be straight in the case of Newtonian fluid. But in the non-Newtonian fluid, it will not be straight, it will be curved. Okay, but which type of curve you will get it in the non-Newtonian fluid will be decided on the basis of dilatant fluid, pseudoplastic fluid, or Bingham plastic fluid. So we have this formula, tau is equal to mu du by dy, or tau is equal to a plus b du by dy raised to the power n. So value of n will help you to decide which type of fluid we are dealing with. Okay, now let's come back to question first and try to figure out what type of fluid is it. Okay, so in this case, they mention like one is moving, one is stationary, and same fluid is flowing in both the situations. So they have given in one case 1 mm, another is 0.25, one is the tau 2 Newton, another is 3 Newton, and they have 2 meter per second, 1 meter per second. So we have to figure out what type of fluid is it. So we have this formula, b into du by dy raised to the power n. Okay, so that n will help you to decide what type of fluid is it. Even we don't know if it's Newtonian or non-Newtonian, so n will help us to find that value. Okay, so in the situation 1, so when we go to first situation, in that one tau is given as 2 and du by dy is also given 2 by 1. So raised to the power n is there. Similarly, we have the second situation where tau is 3 but distance is 1 and the velocity is, distance is 0.25 and velocity is 1 meter per second. So I have both the situations, I divided them. So if you will divide them, it will end up, so b will cancel out each other. So you will be left with 2 raised to the power n, 4 raised to the power n, so which will be 1 by 2 raised to the power n. Take the log on both sides. So you will end up with 0.6. So the value of n is 0.6 and 0.6 is for n less than 1, which means we are talking about pseudoplastic fluid. Okay, so this is the fluid, this is how we figured out. So you just have to know the basic formula, that is tau is equal to a plus b du by dy raised to the power n. You just have to figure out what is the value of n. Yes, this is like a two type of question. One, you should remember a few things. Sometimes people get confused where n less than 1 or greater than 1 means Bingham plastic fluid, pseudoplastic, or dilatant. People get confused. So this is memory based question. And second thing is the concept. You should know how you should approach one specific question. Okay, so the answer for this one is pseudoplastic, and the official answer was also pseudoplastic. Okay, so this was not that much difficult. It's all about you should remember few things. Even if you will reach to value of 0.6, how do you know whether it's a pseudoplastic, dilatant? So you should have to remember few things, right? So that's what you have to do in this question. Now in this question you should have a proper concept. Question number 5. Okay, fully developed flow. It's as soon as the answer key arrived, many of the students tried to complain about it. Like the answer key says that the answer is 0.0074, but many of the students are getting 0.0082. So people get confused, like which is the right answer. So they try to claim like the wrong answer key has been uploaded. But before that, like when I looked back into the question one more time, and I found out like even I solved that question incorrectly in first attempt. So there is a possibility when you go in first attempt there is a very high possibility you will end up with some wrong answer. Okay, but in the second case, like when I looked at this fully developed flow definition very thoroughly, then I understood how should I approach this question. Okay, so first we will discuss like what is the definition of the fully developed flow, then we move on to the question. Okay, so fully developed flow means like there is a pipe. Okay, so as soon as the fluid enters in that pipe, it will take time. Okay, initially there will be a velocity, different velocity profile, and it will not be uniform what we expect. This is the actual velocity profile that we want, and this generally arrives in the case of fully developed flow. So because of which what happens in the initial case, the pressure drop is uneven. It will not be linear. So slowly the dp by dx here will be different, here will be different, here it will be different. So up to there it will continuously change. Okay, so it means at the entrance there is a length le up to where you will not see a proper growth, proper, I mean we haven't reached the fully developed flow in the starting of the pipe. But to understand it, where we get the final where we have the final fully developed flow region, there is a condition which is known as that if you will partially derivate the pressure with respect to that specific direction, it should come constant. So you will see initially the dp by dx is continuously changing, but after some time it is constant, it's linear, it's linearly changing. So which means dp by dx is not changing, right? It's constant. So that's where you have to strike. The question is also the same. If you will look back at the curve, so the curve is like it's little curved, but after some time it's linear. Okay, so that's the same situation here also. So you have to be careful that dp by dx is equal to constant is the situation for the fully developed flow. So you have to find out in the whole data that where we are getting the dp by dx as constant value. Okay, so now a second condition is when you will reach the fully developed flow, there is an equation valid which is the Hagen-Poiseuille equation. So it is applicable only when you will reach the fully developed flow. Okay, so now let's come back to the question. So according to Hagen-Poiseuille equation, we know dp is equal to 4fl by d rho v square by 2. Okay, so this is for the fully developed flow. Just be careful. So now I just put them here and there and try to find the f is equal to delta p by l d by rho 1 by 2 v average square. Okay, so all the values are provided to you, d, rho and all the things are provided. So I put them together. So I put all the values and finally reach with 1 upon 5000 into dp by l. So now you have to just find out where the dp by dx is equal to constant. That's what you have to find out first, because you have to reach to this value, only then this equation is valid. Only then you can find the value of f. That's what they have asked. Okay, so we started solving from the situation 1. So we go step by step, every single curve we go one by one. So 1250 to 1150 dp by dx is 53, then it reaches to 40. So like I am talking about this question, see these values are given, I am taking them one by one. So this is the, then I go with this difference, then I go with this difference. So one by one I am moving forward. Okay, so in this case also, so dp by dx is 53, then it is 40, then it reaches 38, then it reaches to 37 and it again repeated to 37, which means now the dp by dx is constant. So from 1074 to 1000, from 1074 to 1000 the flow has reached, or you can say if the length is I think the length was 6 meter or centimeter. So in the initial 4 centimeter the curve was continuously decreasing. Okay, then it reaches to a constant value, dp by dx get constant. So 4 to 6 is the value, like in this case. So for the fully developed flow, the pressure, initial pressure is 1074. Before that the curve was continuously decreasing, so we haven't reached the fully developed flow, and the final pressure is 1000, distance is 6 minus 4 is equal to 2. Now you just have to put dp by l again in this equation, which we have figured out before. So just have to put the values 1000, this 74,000 by 74 by 10,000, and it will come as 0.0074, and that was the official answer also. Many of the students reached this value 0.0084, because what they did, where they tried to take this value, and then they minus divided by the 5, and they put in that specific formula and they get the answer. But that answer was wrong, correct? Because we reach the fully developed flow only after this value. So this is the reason where you have reached a fully developed flow in the pipe. So up to 4 meter, there was no fully developed flow. It was trying to reach, but this 4 to 6 is the fully developed flow region. Okay, so this was the official answer of this one, and so you have to be careful. Even I did the mistake, and I apologize, because in that memory based paper, memory based solution, I put the wrong answer, 0.0082. It was actually 0.0074. Okay, now moving to the sixth question. It's very easy, although it's a 2-mark question, but still it was very easy. They mentioned that we have 3 types of fluid: A, B, C. Okay, and A is up to 4 centimeter, H is 4 centimeter, and the last one is 2 centimeter. There is a pipe, okay, just in the between section, and the angle is 60 degree at which it is slanted. Now they are asking what is the length of this pipe. How much length do you need to maintain this situation here? So what we have to do is, so this is 2 centimeter given, right? It's very simple. Take the pressure from here, figure out till end here. Similarly, take the pressure from here and figure out till here. And here the pressures are same, right? We know that thing. At same level, the pressure will be same. So what I did, I started from here. P atmosphere, they have not mentioned, so we will consider P atmosphere. It's open to atmosphere. So this is also P atmosphere, this is also P atmosphere. So P atmosphere, then it will reach to rho g h1. This is the specific gravity 1. Then it will reach to specific rho g h2. So finally we have reached to here. So I have taken only 2 centimeter, not 4 centimeter. I end up with this dashed line. So this is the reason where I have taken the pressure. Similarly, from this side, if I will take, or before that, we will need the height of this one also, right? If this is 60, then this will be 30. So I have just taken the perpendicular upon hypotenuse, and I got L6 sin 30, right? So again, now P atmosphere, this pressure, it has reached to here. Now I just need to go here. So I will take rho B GH3. B means because the same fluid is here also. The B fluid is here and the B fluid is here also. The fluid is same. So it means rho B GH3. So P atmosphere to P atmosphere will cancel out and you will be left out with these things. Now only unknown value is L. Rest of the specific gravities are provided to you. Sin 30, you know that 1 by 2. So just have to put the values and L will come as 8 centimeter. That's the answer of this question. It's very easy. Okay. So you have to just remember one thing. At one specific level in that fluid, the pressure will be same. Okay. That's how we solve the question. So wherever they will say, okay, just start from those points and try to bring it to one specific level. Even in manometer also, YouTube manometer also, we do the same way. We have this YouTube, we take out the pressure from both the sides and try to bring it at the same level where the same type of fluid is there. When the same fluid is there, reach to that level and then put them equal and you will get whatever exactly you are looking for in that equation. Okay. So this was the answer of this question. So easy to go, not too much difficult. You don't have to apply a lot of stress also for this question. And the official answer was 8 to 8, though they didn't even give 7.9 to 8.1. I mean, generally they provide this type of situation that you can fluctuate between 7.9 to 8.1. But in this case, they haven't even given that thing also. Okay, so moving forward to the last question of this fluid flow plus mechanical operation solution of GATE 2021. So they have said like we have seawater passing through a bed of resin beads. So we have some type of bed and we have some type of beads in this case. Okay, and seawater is passing through it either top or bottom. Okay, so they are saying the density of the seawater is given, density of resin beads given, beads ka size is also provided, void is also provided, acceleration gravity is also given to us. So they have asked what is the pressure drop across this point and this point. So across the bed, what will be the pressure drop at the onset of fluidization? So first we have to understand what is the meaning of onset of fluidization. Let's have a quick view of this onset of fluidization. So fluidization means we are generally talking about there are some particles in a bed and you are passing the fluid from the bottom, okay, and you keep increasing the velocity of the fluid. So there is a situation comes, so pressure, so as you keep increasing the velocity, the pressure drop across that specific bed will keep increasing. Okay, so the pressure drop will keep as you keep increasing the velocity of this fluid, the pressure drop will keep increasing across the bed, and there is a situation will arise where the upward force will be equal to the weight of the bed. This situation will arise where after which the particles will start coming in the suspension state. They will be suspended, they will be like floating. There is a fluidization situation will come in the bed also. Okay, so that's what they are saying. So the upward force will be equal to the weight of the particle, which means the particles will be suspended. So now this is the situation where we are talking about the minimum fluidization, minimum velocity, minimum situation where you will start seeing the fluidization in the bed. So this minimum fluidization, onset fluidization, incipient fluidization, everything is same, and it is equal to, so and this situation will you will calculate this minimum fluidization on the basis that pressure drop across is equal to weight of the bed minus buoyancy force. You just have to figure out this value, and delta P will be equal to G into 1 minus porosity into rho P minus rho into L. L is the length of the bed, density of the particle minus density of the fluid, porosity into my gravitational force, and it is equal to the pressure drop. That's what. So here they have asked what is delta P by L. So you have to take this L also on this side and you will end up with the solution. So like I repeat again, so we have given the two densities, the particle size, porosity, and 9.8 meter per second square. We have to calculate delta P by L. So it means we don't need the diameter of the particles here. So you just put it in the formula, 9.8 into 1 minus 0.41330 minus 1025, and you will end up with 1793.4 kg per meter square per second square. So that is the pressure drop per unit length across the bed at the point of minimum fluidization or onset of fluidization or incipient fluidization. Okay, so that was the solution of this question, and that was also easy. You just have to remember the formula and you are good to go. So there were some questions where you will have to understand you have to thoroughly go through the question 2-3 times to understand what exactly they are looking for. Like I told you, if the column is very lengthy only, then you can come to this conclusion that the particle can reach the fluidization situation, terminal velocity and all those things. So this type of questions you have to thoroughly understand it. In some cases you have to remember the things also, like which type of fluid you are dealing with, right? Like in the case of it's Newtonian, non-Newtonian. In non-Newtonian it's dilatant, Bingham plastic or pseudoplastic. So you have to remember the values of N also, right, to explain that specific problem. So these are the things like it's conceptual based, numerical based, and memory based. So all type of questions were from the fluid flow plus mechanical operation. So this is the official answer for the last question. We reached to 1793.4, which comes in this range 1790 to 1800. So these are the 7 questions from fluid flow plus mechanical operation in GATE 2021. So that's it for this video, guys. So very soon we will have more videos related to the GATE 2021 solutions. So keep watching, and all the relevant links are in the description box. Go through it. All our videos link and handwritten notes, chemical books, textbooks, which one you should recommend. So all these things are in the description box. Go through it, and if you find it worth it, just give it a try also.